Thank you and good morning. It's a great honor to be here. This is really a nice conference. I wasn't here last year. It's my first year, and I really like the dynamics of the conference. It's unlike a lot of conferences you go to where people like when you get up and make a lot of presentations and there's not a lot of back and forth, and I think that's really what sets it apart, and I really appreciate that. So as Murli said, I'm an automotive guy. Just recently now looking beyond automotive into this thing called the smart grid, and I remarked to Joe yesterday after his presentation that I have been making the mistake of calling it the smart grid. We should really be calling it the smarter grid, because it's pretty smart right now. In spite of terms like peaky load, which I had never heard before, it's a pretty smart system, and I think we need to find a way to really to tap into all the potential that exists. I'm going to talk a little bit about a couple topics here. My main goal is to talk about collaboration, but I think it's maybe important to do a little not promotion but explanation of who Infineon is and where we come from for those who may not know who we are. Talk a little bit about what we see as the need for vehicle electrification and how that really is we think a catalyst for the smart grid. Then get into collaboration, some real-world examples that we deal with in the world that I operate or operated in automotive. So Infineon, we're one of the many spin-outs of Siemens. We were Siemens Microelectronics, so we're about 40 years old as a company working on semiconductors, broadline semiconductor supplier. Our main focus, which you see every time we talk, is energy efficiency, mobility, and security. About a $3 billion business, 25,000 people, and we're driven by technology, as you can imagine, being a semiconductor company. The way we come to the market, the way we look at the markets is we really focus, as I said, on these three areas, and we combine that or merge that with what our technology, our core technology attributes are. So that would be, of course, analog, power electronics, embedded control, and manufacturing process, and we take that combination, and really this is what allows us or enables us to create the target focus from a market standpoint of automotive, industrial electronics, and chip card security. So automotive, I think, is pretty clear. That's where I came from. As a matter of fact, until January, I'd spent the last 20-some years in automotive in different jobs. Industrial electronics, I think, is pretty clear. So that's everything from driving trains to running plant equipment from an electrical standpoint, and then chip card security, which may or may not be so clear. It's the contact or contactless ICs that are in banking cards in Europe or passports here in the U.S. So that's basically our business structure. We are our position, if you will, is this was always the story. We were either number one or two fighting with Freescale, and then Renesas did this crazy thing of buying NEC, or the other way around, I'm not sure, and now we're number two or number three is the battle, but ultimately we'll work our way again up to the number one position. Power electronics, again, we hold a very strong market position there, and then in chip card. So vehicle electrification. We heard it yesterday from a lot of people talking about vehicle electrification, whether it's EV or HEV or PHEV. There's no doubt that it's coming. You can find oodles of data and slides to predict that it's coming and what rate it will be and what volume it would be. If you look at these progressions, it's clear that across the world it'll be distributed. There are different charts that you can find that talk about the mix between HEV, EV. It's all over the map. From our standpoint, I can almost say we don't care, because we're a semiconductor guy, and whether you're putting it in a fuel cell or whether you're putting in an EV or plug-in hybrid or a hybrid, for us there's plenty of business opportunity. What we do think is that when you look at the grid, there's a lot of reasons that the grid is going to take off. But from our perspective, where we live in the value chain, we really see the electrified vehicle as an enabler. You could say, if you're on the energy side, maybe it's not so true. But if you are in a neighborhood where 3 people buy an electric vehicle and you blow your transformer, I can tell you there's a few people in that neighborhood are going to be believers in a smart grid, even if they don't own an EV. So we really think that the EV will really drive in an enabling way what the smart grid, how fast the smart grid will progress. And from our standpoint, again, on a business side, we cover the entire smart grid from a product side, but we really focus in vehicle electrification as one of the key enablers. And if you look at vehicle electrification, this is, hopefully it's clear, this is a meter and this is a car, and really this is what it is. It's a convergence of two industries. I can't speak for the electrical industry, but the automotive industry, we typically don't work well with anybody, even ourselves. So now we have to come to this point where we have to collaborate with other people outside of our industry. So it really is a huge challenge. And coming from automotive, I know that price is number one. Buyers at the OEM, and when I was at GM, we wanted to know what was the material cost of the parts that were going into the parts that we buy. So cost had to be the lowest, quality had to be the highest, reliability had to be the highest. When you look at industrial energy or electricity, I always say, well, price is good, it's important. Quality and reliability isn't at the level of automotive, and I've had this debate with people I've met now in my new job and say, oh, you don't understand. It's just as important in industrial electricity as it is in automotive. And I say, really? I have 30 years of driving experience. I've owned over 20 some cars probably, and I've walked home one time. But at my home in Michigan, I lose power 3 to 5 times every year. So I would say that the expectation of reliability and quality is different from automotive to the industrial electrical world. Quite different. So as a semiconductor company, we can look at this as purely a business play and say, this is a subtle, shameless promotion of product that I'm sneaking in here. We can look at what the opportunities are on the application side, from inverters down to DC-DC chargers. We have a product offering that include these things called hybrid packs. For those in the power industry, you're probably familiar with them. We also have the discrete devices. So we could just say, hey, this is a great opportunity for business, but we really think that there's more happening here than just the business opportunity. Today, if you look at today's world, this really is a good explanation of really a paradigm shift that's happening. Fuel injectors, basically a mechanical device, is the key driver of performance. It's supplemented by semiconductors, but when you get to electrified vehicles, it's exactly the opposite. The semiconductor really is the key driver for vehicle performance. It's probably, I know batteries are very important, but when it gets down to making sure you get the EMPG, electric miles per gallon, as high as possible, batteries help you with range, but the efficiency of the conversion of power is critical to the miles per gallon. So this is another, I would say, dynamic factor really that affects the business for us. If you take your traditional powertrain semiconductor bill of material in a traditional car and compare it to a hybrid, right now it's almost 3 times the BOM. So the business is huge, and even with the improvement in efficiencies, the driving of costs down, it's still going to be over 2 times the bill of material. So for us, it's great news. You don't have to sell as many cars for us to still have a really viable business. As a matter of fact, on average, you could estimate about an 8-inch wafer per car. So on the semi side, that's pretty good business. But it comes with some issues. So if you're familiar with automotive business, I think you probably can use this model just about anywhere. You take a base technology, you have some application know-how, and we do this thing called development and validation, which is pretty critical for cars, so that you don't have to walk home 3 or 4 or 5 times a year. And it's based on this, a lot of factors, but basically from customer needs, requirements, specifications, all the way down to the component. When you look at vehicle electrification, the base technology of lithium-ion batteries is here. Everybody in this room has a couple at least. Power electronics is not new, it's been around a long time. It's really in the area of application, where we're taking an application of lithium-ion batteries and power electronics and marrying them together in an environment they haven't been, there's not a lot of experience. And that's where the greatest opportunity for success is, and also where some of the major opportunities for failure lie. If we take, for example, the safety collaboration, which is pretty interesting. If you go back to the Breed ball and tube, which was the little mechanical device that told the airbag to blow up, to the last decade's very advanced safety programs, this is 40 years. So that's a pretty long time, and far more serious consequences on the safety side than saving miles per gallon, so the impact on people's lives. On the electric side, electric drivetrain, we're not going to have that opportunity. So, of course, we have a president who's given us, this is not the latest chart because somebody pointed out I misspelled his first name, but we have a president who's given us this nice challenge. There are a lot of other factors that are driving us, and although we have some experience very early, we have very successful entrants here driving from Toyota, and we have these new players coming onto the market. It's going to require us to find really a way to collaborate that's very efficient and very effective. And when you collaborate well, it's a thing of beauty. It's kind of like this. I love this picture. Everything is working well. You can also see there's not a lot of room for anything to not go well. But sometimes things don't go well when you don't collaborate. And I love this picture for a lot of reasons. Probably the most important reason is that you can see the anchors are out, which is really important in boating, so you don't lose your place. But you could see that a little bit of collaboration between the pilot house and the anchor room might have resulted in the anchors being out, somewhere way out there a little bit earlier. And you look at automotive and you say, even where we sit today, we see opportunities where there was missed collaboration moments. So at Infineon, we often joke about the current hybrid systems that are out there. The power electronics, the actual IGBT modules, we're sure archaeologists are going to find those 1,000 years from now and the car will be gone. But the module's going to survive because it is so over-designed. The cost that we've put into it, the technology is the best. It'll never fail. It'll live forever. But that comes at a price. And the only way that you can get out of that model where you throw everything at it, including the kitchen sink, is you have to collaborate. So from our standpoint, we look at collaboration really as there are 6 key elements. 3 of these are what I would call hard factors, and 3 are soft factors. So aligned goals. It sounds easy, but when you take 2 or 3 companies that are typically had a very traditional relationship in the supply chain, it's not so easy to align your goals. It's not easy for me to align my goals with, say, a Delphi and then with a GM. It takes some work. It takes some discussion. It takes some buy-in from not only the engineers at the engineering level, but the management above them to make sure that the goals, once they're aligned, we stay on track. It takes expertise. If you don't bring expertise, you don't bring much value to a collaboration. You have to bring some expertise. It takes some process or some structure. We used the word yesterday, collaboration, a lot. I think almost every speaker used it. But if you're truly going to collaborate around design, you have to have a process by where people come together, they review, they have technical reviews, technical gates, design reviews, a lot of structure in collaboration, more than just saying, hey, let's collaborate. On the softer side, you got to have some elements, and especially coming out of automotive, while it may not be a surprise to other industries, these are usually not words that are thrown around so freely. You have to be cooperative. The whole group of people collaborating has to be cooperative. You can't be in a highly, visionary, collaborative relationship with a group of companies, and one of the companies is either your customer or their customer. You have a business issue down the hall, because companies that do business together always have business issues where you're shooting yourself in the foot, and they come into this meeting and stop all collaboration. That can't happen. It does happen, but to have this kind of collaboration successfully, you can't do that. You have to have flexibility. Again, not really a hallmark word of automotive. We're not typically known for our flexibility. And trust is another word not commonly thrown around. And trust ranges from what you think when you look at your significant other and how much you trust them, to what you think when you look at a drooling 70-pound bulldog on the other side of a chain link fence. You trust the fence, not necessarily the dog. So to collaborate effectively, we think you have to have these elements. And this